All right, in this video, we're going to be talking about continuous growth and decay formula. For all real numbers t, all positive numbers a and r are continuous growth or decay is represented by the following formula. So this right here, this is the formula we're going to be using. Notice we are using the special letter E, right? Euler's number. Here's our A that goes in the front and our R, which is our rate right there. So A is an initial value. R is the continuous growth rate per unit of time. T is the time that's lapsed. So if R is greater than 0, the formula represents a continuous growth, right? Which makes sense. So if R is positive, then that means that we have a growth. So our entire A of t is going to be increasing. Okay, so we have growth. But if R is negative, so now if R is negative, then our A of t is going to be decreasing. So it's going to be a continuous decay. Okay, so for business applications, the continuous growth formula is called the continuous compounding formula. So you might have heard of that before. And it takes the form of P is the principal and initial invested. R is the growth of interest rate per time, and T is the period of terms per investment. So some of you may have seen this formula before and notice that it spells out PERT. The biggest difference that we use a different variable A instead of P for that principal value. All right, let's take a look at an example. Take a look at two different examples here. So a person invested $1,000, right? So this is my A value. My A is going to be $1,000. So let's write that down. In an account earning a nominal 10% per year compounded continuously. So the moment we hear this word continuous, right, we need to start thinking of exponentials for this. So that means we're going to be using our function, A of t is equal to A e to the RT. All right, so we know that the rate is going to be 0.10. Okay, that's our rate. And now how much of the account do we have at the end of 1 year? And so that tells us that our t value in this case is going to be 1. Okay. All right, so these are the big things that we got, 10% compounded yearly. So now we're going to go ahead and plug all of this in. So we get A of t. All right. Our initial amount, that's the $1,000. We're going to plug that in. We have E, right? And then we're going to take 0.10 and multiply that by t, but t is equal to 1. Okay, so now we can go ahead and plug this into our calculator. So I came over here to the decimal scientific calculator, so we're going to do 1,000. There's 1,000. Function, we are going to click on e to the x right here. And then because we're going to input a couple of values, let's go ahead and make sure we use parentheses. So we're going to say 0.10 times, and in this case it's times 1, so it's not going to change much, but I just wanted to make sure I demonstrated that. So notice that this is our formula. Here's our A value, E raised to the 0.10, that's our rate times the year. So we get that the A of t is going to be 1,105. So let's go ahead and write that down. So it means that we're going to have 1,005.17 is our A of t. So how much was in the account at the end of 1 year? So at the end of 1 year, we had 1,105.17. All right, take a moment and try this next one. All right, I didn't fully write out the entire solution just yet. I wanted to highlight a couple of things. So because we're looking at the decay, this is big flag that this is going to be a negative rate. So even though it's not written as our rate is negative here, right? We do have to come over here when we write out that rate and state that it is going to be negative since we have this decay going on here. We do have our A, our initial value is going to be 100, and we can write mg's, that's fine. And then we have the decay in terms of time is going to be 3 days. So then we're going to go ahead and write out our formula. So we get A of t is equal to 100 e to the negative 0.173 times that by 3. Okay, and so let's go ahead now and come to the calculator, and let's plug that in. So we have 100. We're going to come over to functions, click on the E, go back to the main. Let's go ahead and put in our parentheses. So we're going to have negative 0.173, and then that's going to be multiplied by 3. We're going to close those parentheses and hit enter. So notice our value is going to be this 59.51. So our A of t is going to be 59.511. Okay. So we'll finish this off by saying, it's asking after 3 days. So let's say after 3 days, there will be 59.511 mgs left of random 222. Okay. All right, and that's the end of the section.